Hi there. Last time we talked about empirical formula, and as promised, this is the follow-up to that video where we're going to discuss molecular formula. So if you remember, an empirical formula is just taking the molecular formula and reducing those subscripts down to the lowest whole number ratio, whereas the molecular formula, and this is important, is the actual formula of the compound. Okay, so if you remember, we used that example of glucose, right? So the molecular formula gives you the composition of the molecules that are actually present. So it tells you how many of each atom are actually in the compound. And you can represent it as a multiple of the empirical formula. So you remember our empirical formula for glucose was CH2O. Okay, so 1C, 2 H's, 1 O is the lowest whole number ratio. But if you multiply each of those subscripts by 6, what you get is you get glucose, okay, which is C6H12O6. So it still keeps those subscripts in this same 1-to-1 ratio, but then you get the actual formula, okay? So there can be more than one molecular formula for most empirical formulas. Okay, so in order to calculate molecular formula from the empirical formula, you do need the molar mass. So let's do an example here. So let's say we have a white powder analyzed to have an empirical formula of P2O5. The compound has a molar mass of 283.88 grams per mole. What is its molecular formula? So what you want to do is you want to actually calculate the empirical formula mass, right? Where you take the empirical formula, so we're going to take that P2O5, okay? And we're going to treat that the same way we would if we were calculating molar mass for a compound. So we're going to take, so we have two P's, okay? So we're going to take 2 times phosphorus, which is 31.0. Okay, and then we're going to add that to 5 times the atomic mass of oxygen, which is 16.0. So we need a calculator here. And that is, oops. Gives us 142. Okay, so now in order to figure out what we're going to multiply our subscripts by, okay, we take our molar mass that we're given, which is this number, and we're going to divide by the empirical formula mass. Okay, so take our 283.88. We're going to divide by 142. You get 2. Okay, so that number becomes the multiplier. So multiply subscripts by this number. Okay, so what we're going to do is just like we saw with our glucose formula up there, we're going to take our P2O5. Okay, put that little subscript of 2 there, and let's see what we get. Okay, so 2 times 2 is 4. 2 times 5 is 10. So P4O10 is our molecular formula for this compound. Right, so the empirical formula calculations are actually, the harder part. Once you get the empirical formula and the molar mass, it's not a really difficult calculation. Okay, so this time we are given some percent composition data for a compound and a molar mass. So what we first have to do is we have to figure out our empirical formula. Okay, so determine empirical formula and a molecular formula. So remember, when we have percent composition, we just pretend like those are grams. 4.27 grams. And let me bring those elements down as well. And then 4.07 grams of H. All right, we'll convert each of those to moles by using the molar mass. So this guy is 1 mole per 35.5 grams. This guy is 1 mole per 12 grams. And this guy is 1 mole per 1 gram. Gives me 2.02 moles, and 71.65 divided by 35.5. That gives me 2.02 moles. Right, divide everything by 2.02. All right, so my empirical formula is Cl1CH. So now I want to calculate, oh, sorry, H2, forgot that. So now I want to calculate my empirical formula mass. So I've got Cl, which is 35.5, C, which is 12, and H, I've got 2 of them. Add those up. I get 49.5. So that's my empirical formula mass. So now I want to take my molar mass, which is 98.96, and divide that by 49.5. 98. Get 1.99999, so round that to 2. And I get Cl2, C2, H4. And that is your molecular formula for this compound. So not too bad, right? So for this example, we had to do all of our steps. So we had to first determine our empirical formula. We should label, right? Here's our empirical formula. We did that by using our percent composition data, converting to moles, and then dividing by the lowest number to get those in whole number ratio. And then we used our empirical formula, calculated empirical formula mass, took our molecular mass or molar mass and divided that by that number to give us our multiplier for our subscripts. And we were then able to get our molecular formula. So I hope that helped. We will do more examples of this together in class. And as always, if you have any questions, feel free to reach out and let me know. Thanks a lot.